greater than 0, what can you tell me about the circle with regard to the x-axis and or theta equals 0? It'll be above the pole. If A is less than 0, the circle is going to be below the pole. Yes. Yeah, I'm going to go stand back here and get some people behave. Okay, now we need some identifying features. So say you're given r equals 4 cosine theta. R equals 4 cosine theta. What is it?
Oh,
it's a circle.
We didn't finish this part.
Yeah, we did.
We did?
We said it out loud.
Okay.
What can you tell me about what is the radius? What is the center? 0 degrees. Is it above, below, left, or right? So it's right of the pole. Okay, r equals -3 sine theta. What can you tell me about it? It's a circle. Circle below the pole with a radius of 1.5 and where's the center? Nope. 1.5 where? You could put 270 degrees. You could also put -1.5, 90 degrees, right? We did those with reflection.
Oh,
or symmetry, I'm sorry.
Would it be negative 1.5?
Well, reflection will work too, huh?
Would the radius be negative 1.5?
No. Because the radius is always going to be a length. Therefore, it'll be positive.
So it doesn't matter.
Okay. Okay, now we're supposed to convert these to Cartesian. We don't need to convert both of them. Is there one you'd prefer to convert?
Let's do the positive one.
Because we haven't done a negative one. So we would do r equals -3y over r, since it's sine. Multiply across by r, we get r squared equals -3y. X squared plus y squared equals -3y.
I got you.
X squared plus y squared plus 3y plus something to complete the square. 3 over 2 squared. What we do on one side, we've got to do the other side. So x squared plus y plus 3/2 squared equals 9/4. So that tells you you have a circle that went down 1.5. It has a radius of 1.5. Here, you keep the y. Whatever's in this parentheses goes in here, including the sign, and then it's just squared. Because if I multiply all this out, you'll get that. The x did not have any movement. It didn't move left to right. That's why there was nothing to complete. We okay with that? Yes. We did use symmetry.
Oh, I'm sorry.
Okay, here we go. The next one, theta equals 135. This is like the easiest one of all.
What?
It's a line through the pole at that angle. So it's a line through the pole at that angle. Now let's see if we can figure out how to convert this to Cartesian. First of all, if I put that, If I put that on a Cartesian, could you tell me what the slope of the line would be?
No.
Would it be positive or negative? It'd be negative. It'd be -1. So let's take a look. Can you tell me what is tan of 135? Yeah, but I want the actual things. Isn't this negative square? It's not negative, I lied. It's square root of 2 over 2 over negative square root of 2 over 2, which is negative 1. So that means my slope is negative 1. This one goes through the pole, which on Cartesian means it would go through the, so therefore it's just y equals negative x.
Oh, just look at it and say that.
So all you have to do is figure out at that angle what are your points, and that'll get you your slope because it's going to be direct variation.
But if it's like 45, it's going to be x.
Yes. Okay, ready for the next one?
That show is, I actually watched it, like, I tried rewatching it, and I realized how bad.
Are you going to keep talking?
Yeah. No.
Don't. Looking at the next one, once again, we have sine in the denominator. If we have sine and cosine in the denominator, that's telling us it's a line. If you just have sine or you just have cosine, then we're talking it being either horizontal or vertical, correct? So if this is sine, is that y's or x's? It's y's. So I literally can go 1, 2, 3, and I happen to know this is going to be y equals 3. Well, let's do a couple other points just to cover our bases. So how about we do, let's do 60 degrees. 3 over sine, no, I'm going to do 30 degrees. 3 over sine 30. What's sine 30?
Square root of 2 over 2.
No, it's not.
It's,
What?
1/2. So 3 divided by 1/2 would be 6 at 30 degrees. So then I go over here at 30 degrees and I count out 1, 2, 3, 4, 5, 6. Wouldn't this be symmetrical across theta equals 90?
Yes.
So can I run it all the way over here to 150? You see how you get that horizontal line?
Lemon squeezy.
You okay with that? Okay, so then let's convert this. What will we do first?
Sine equals y or r.
How about let's just move the sign.
What?
What is r sine theta equal? Y equals 3. And when you look at our graph, isn't that y equals 3?
I guess so.
Wait, hold on.
Huh?
Guys, it makes sense. Just look at it.
Oh, you multiply. Yeah.
Yeah, it makes sense. Just look at it.
Okay. Okay, we okay with that? Yeah. Huh? Yeah, this could also be written as 3 cosecant theta. Sometimes they'll give it to you like this piece as well. And you know, so you just got to get it in your mind. Hey, if I move this around, will sine and cosine end up in the denominator? Okay. Take a look at the next one. Can you tell me anything about what r cosine theta equals 6 would be? If I simplified it for r, then it would be like this. So now I know cosine's in the denominator. And of course, this is a quick turn to r equals 6. So now talk to me about that vertical line. That vertical line would be left or right, above or below of the pole?
Right.
Right of the pole, how far?
6.
6. Therefore, there would be a point at
0.
60 degrees. Very good. Okay, this is the one you may not have picked up on yesterday. Too bad, you should have. Let's look at 0 degrees. So say I've got, I'm going to blow this up so I can write in it.
Whoa! You can't say that.
I'm going to kick you out of this room, I swear. 0 degrees minus sine 0 degrees. Okay, so what is cosine 0 degrees? 1. What's sine 0 degrees?
0.
So now I have 3 0 degrees.
Where'd you get the 1 from?
What's cosine of 0 degrees?
Oh, wait, yeah.
Okay, do you see that there's a 1 right here? what does cosine have to deal with, x's or y's? Do you see that this right here is 3? And that would be the x-intercept, correct? Because 3, 0 degrees, isn't that the same thing as 3, 0 in Cartesian?
Yeah.
So therefore, that gave me the 1, 2, 3. Basically gave me an x-intercept. By knowing that, could you tell me what you think the y-intercept would be if it were on Cartesian? -3. So in other words, -390. So I have an oblique line. So you got pieces going on there, right? So now when I do sine of 90, I got 3 over cosine 90, sine 90. What's cosine of 90? What's sine of 90? So now I have -3 of 90 degrees. So when you have both cosine and sine on the bottom, you're actually able to get intercepts. And line. We okay with that? Do you expect this to be a positive or a negative slope? Positive. Do you happen to know what the slope would be? It's 3 to 3, isn't it? It's just 1. Okay. So if we're going to go to convert this to change it, I got what? All kinds of stuff going on. What would I do first?
I would do multiply that to the other side.
Yeah, why don't we do the same thing we did a while ago? Let's do multiply that so we can get it to the other side and get the 3 by itself.
Okay.
Now what can I do?
Now we're going to go.
If you square it, both sides, then cosine squared.
Yeah.
You realize that if you square that, it's cosine squared minus 2 cosine sine theta plus sine squared.
Stop you there. We're just gonna.
Oh, okay, we could do that. That works. So then we have x minus y equals 3. So y equals -x. So y equals, oh, whoops, there's a +3 there, sorry. X minus 3. We okay with that? Yeah. Okay, so this first one, there's actually some stuff that didn't print. This would be r sine theta equals a constant. If r sine theta equals a constant, or if r equals a constant over sine theta, you have a horizontal line at y equals whatever the number is. The next one is going to be r cosine theta, which would be the same thing as a constant over cosine theta. This is going to be a vertical line, x equals whatever the number is. The next one's the easiest one. Theta equals some value. This one's great. It's just a line through the, which means this is going to be a y equals mx1. So this is just y equals mx, while these up here are y equals mx plus b. No, ignore that last thing I said. This one is y equals mx plus b. Okay, so now we have an oblique line, right, which is just a diagonal.
Yeah. If you want to call it that.
And that's going to be where we have some constant, and we got cosine theta plus sine theta, or some other arrangement with regard. So now you have an example down below. Can you figure out the identifying features for that polar equation?
I bet. So that's going to be diagonal.
What type of line is it?
Oblique.
It's an oblique line. Can you find two polar points for it?
For sure.
How we do 0, so 0
X, right? So that's
So 1.50 degrees.
And the y-intercept is 3 or 0.
390 seconds.
270. Why 270? 90.
90.
Yeah, why 270? It's a positive 3. It's a positive 3. Yeah, but it could be above or below, right? Okay, so now I want you to think about converting this one. This one's going to convert a little different, isn't it? By looking at it, can you tell me what you think is going to happen? For example, do you know what the slope of the line is going to be? This oblique line in Cartesian? We think it's going to be 2. Negative? You think it's going to be negative?
Yeah.
Look at it.
Okay. I'm just asking. Okay, so let's convert it and let's find out. First step in converting it, we do r to cosine theta plus sine theta. Y'all want to distribute the r again? So we get 2r cosine theta plus r sine theta. So we get 2x plus y equals 3. So y equals negative 2x plus 3.
That's about right.
We okay with that? Questions, problems with that? What do I get? Everybody agree? Everybody agree? So then I would go toward 90 and I would count out 6, right? 1, 2, 3, 4, 5. And that would be my point right there. The next one I'm interested in doing, let's do 180. 3 plus 3 sine 180. Three? Do you agree? I totally don't agree. I totally do agree. I was thinking I was doing a different one.
Ended yesterday. Good luck to all the people on the ballot.
Sorry, my bad. I was thinking I was at 270. That's the one I was thinking I picked. 3, 3. Zero. Okay, so I want you to remember that these have, this is sine, correct? Which means it's going to be symmetrical over the y, or where theta equals 90. So this 3 right here at 180 can go the other direction towards 0 as well. So now I'm going to leave y'all. Y'all need to do 120, 150, 210, 240. Spread them out. Everybody don't do the same one. I don't want to write all those. Totally. Let me know when you got one.
Two 10 is 1.5.
210 is 1.5. 5.1, 2, right? So I'm just going to put 5.1.
150 is 4.5.
150 is 4.5. Yes, it is. I agree. I think 120 is 5.6. And then we got 240 left. 0.4. Okay, so now we're going to go to graphing these. So we've already graphed some. We got 5.6 at 120. So if I go toward 120, I'm going to count 1, 2, 3, 4, 5, and about right there. Didn't show up very well. I'm blowing it up on mine. It's not blowing it up over there. Okay, so now to graph its buddy, I'm just going to slide right along that circle over to 60 to plot it. So I just kind of stay at my value and I slide across over. Are you looking at me? So I've got my point and then I just go around to the other and I follow the circle around. Then the next one we got is 4.5 at 150. So 1, 2, 3, 4.5. And once again, I'm just going to slide around that circle all the way around to 30. You could recount it if you want. I'm not really interested in doing that. And then we got 0.4. So at 240, we're going to do 0.4. So that's going to be just right there. And then right next to it, we'll do another. And so you can see how if you go to connect these, you get that puffy heart. Now, a cardioid has a point at the pole. A limason with a loop has a point at the pole. But a limason with a dimple does not touch the pole. Okay, so if you're sitting there and you notice it's not at the pole and you're trying to figure out if it's a loop or a dimple, if it's not a pole, then it's going to be just a dimple. And the reason I say that is because sometimes it's difficult to see the loop. We okay with this? Okay, I'm going to have to get that thing to follow me. I don't know why we're not. Oh, there we go. Okay, so what symmetry do you notice? Okay, so I'm going to say theta equals 90 degrees, right? We also would refer to this over the y-axis, and we'll all know what we mean. Now, when you're talking in polars, if you're asking a question, it'd be better to say theta over 90. What else could you say? Theta equals 270. So here are your details for it. We did sine. So A plus or minus A sine theta. Notice they're both A. That means the number's the same as if it's a cardioid. This one's going to be symmetric across the y-axis, also known as theta equals 90 degrees. And notice the degrees that were given to you to find points, 90 to 270. If that A value next to sine, if this one, or in other words, if it is minus, then it will be below the pole. If it's positive like ours one, it'll be above the pole. Then you go up to cosine. This one's across the x-axis, or theta equals 0 degrees. Notice for cosine, they gave you 0 to 180. We want to get the points for half of it so we can reflect to the other side or find the symmetry. Then we have, if that A next to the cosine is negative, it would be to the left of the pole. If it's positive, it'll be to the right of the pole. We okay with cardioids? Let's move on to, this is going to be a limason. Is it going to have a loop or a dimple? It's going to have a dimple. How do I know? Because the A is greater. If the B is greater, ignoring signs, if the B is greater, then it's going to be a loop. In this case, is it going to be left, right, above, or below the pole? Should be left of the pole. Cosine already gets rid of the above and below, correct? And then we just got to look right here. Is the number next to cosine positive or negative? If it's negative, then it's going to be left of the pole. So now we have an idea of what we're graphing, which will help us tremendously. Look at the first one, 3 minus 2 cosine 0 degrees. What's that going to be? Everybody agree? So this is my dimple. That one's not going to have any symmetry for me. If I go down to 180, what's 180 going to give me? Five. So that's technically going to be where our symmetry is. Then we're going to go find some above, and we're going to reflect them to down below. So we need, what's 90 going to be? So just 390. So if I go 1, 2, 3, I got 90, then I'm going to go the other direction, 1, 2, 3. We okay with that? Okay, now we have to find all the ugly ones. So we need 30, 60, 120, 150. Two.
120 is 4.
120 is 4. Oh, 180 was 5. Do what? 1.2?
3.
1.3.
150 is 4.7.
4.7. Okie doke. So now let's go plot some points. So let's see. I got 1.3 to 30. So 1.3. And then I'm just going to go right on around to 150. No, I'm not going to do that at all. I don't know what I'm thinking. Sorry, wrong way. Undo. Where's my undo button? There it is. Undo. Okay. I'm going to take that right on around to whatever that is. 330? Yeah. Okay, then we got 2 at 60. So when we do 2 at 60, and then I'm going to slide that all the way around to 300. 4 at 120. And I'm going to slide that all the way down to 240. And then our last one was 150 at 4.7. So almost to 5. And then I'm going to slide that right down to 210. And then I'm just going to take it and start connecting my points. And you can see how your limacon with a dimple does not touch the pole. Now, when you start doing a loop, it can get a little confusing because you're going to come around and you're going to hit, I'm going to draw on this. Don't draw these on yours. You're going to have this, and you're going to have something right here, and then you're going to have some stuff right here, and it's going to be a little confusing what you're supposed to do. But all you would do is come down through, make your loop, and then go on out. Okay? I just want to give you a heads up when you do your first loop. They can be a little, you got these points, you're not sure what to do with them. Okay, so in this case, what was our symmetry? We had cosine, so we had what? Theta equals, 0 degrees. We could also say theta equals 180. And of course, if we talk about the x-axis, we know what we're talking about. Just keep in mind, what are you answering the question to? So here they give you your scenarios of a limacon. You got A plus or minus B. You have an A and a B because these are different values. If the B values are negative, then for a cosine, it will be left of the pole. For a sine, it will be below the pole. Notice your cosines get 0 through 180. Your sines get 90 through 270. And then they basically talk to you about if A is greater, then it's going to be a dimple. And if B is greater, then it's going to be a loop, ignoring the signs. So then our last couple, we're going to go ahead and do the rows. And this will get you done with me. So you just got time to go back and practice some stuff. Make sure you know your vectors, your parametrics, and we get those quizzes retaken. So looking at this first one, and roses are like totally different. They can be pretty easy and they can be pretty tedious too. So in this case, how many petals do I have? 4. If the number is even, then you double it. If the number is odd, then that's the actual number. And then this right here is actually the length of the petal. You don't do a table like we do with the other. We do the max and the min. And when I'm talking about the max and the min, I'm talking about where does sine equal 1, where does sine equal -1? Or if it's cosine, where does cosine equal 1? Because that's their max and min. The only time you have to do the max and the min is if the number of petals are even. So in this case, we're doing sine. Sine has a max of 1 where? At 90 degrees. So we're going to do 90 degrees. But here's how we do 90 degrees. It goes 6 sine. And this right here is going to have to be 90 degrees. How do I get 90 degrees, though, when it's 6 sine 2 times something? 45. That means my answer is going to be something 45 degrees. So what do we get? 645. And this is going to be the length. So when I go to 45, I'm going to count out 1, 2, 3, 4, 5, 6. That's the length of my petal. That's one of my petals so far. Then we're going to do the minimum. The minimum is going to be 6 sine 2 times something 135. So that means my answer is going to be something 135 degrees. -6. So now I go up to 135, but instead of counting toward 135, I'm going to count toward 315. So 1, 2, 3, 4, 5, 6. Do you see how those two happen to be symmetrical over theta equals 0? Okay, so now we're ready to use our symmetry. We can go around to each of the 45s. So over here at 225, I can put that point. And then over there at 135, I can put that point. Because it is even, you're going to see symmetry everywhere. So all that did was give me the end point of each petal. You can't just draw them now. You have to know the width of each petal as well. This is the tedious part. So we're going to do both 30 and 60. So I'm going to do 6 sine, and I got to get this to equal 30, and I'm going to do 6 sine, and I got to get this to equal 60. So 2 times what is 30? So it's going to be 15 degrees, which means my answer will be 15 degrees. And then this one is going to be 2 times what to give me 60? So that means my answer down here is going to be 30 degrees. The thing we mess up on this is whatever answer we get for the radius, we do it with 60 degrees, and then it's all kinds of messed up. You have to think about what value did I actually plug in. So what did we get for 6 sine of 30? And then what did we get for 6 sine of 60? Everybody okay with that? Yeah, you just have to remember to use the right angle. Because where that 15 is, I tell you all the time, I'll put 30. So I actually instead automatically go down and write my point and put the angle so I don't forget, because I always do. Okay, so we got 315. Now this one has lots of stuff we have to do with regard to symmetry. So 315, if I go to 15, it's going to be 1, 2, 3. Now think about a pedal. A pedal has a seam down the middle. That's going to be where that furthest length is. So now I'm going to, what I do is I count how far away it is from my seam. So I'm going to draw this so you can see. Let me blow it up really good. So I got 1, 2, 3 away from my center. So I'm going to count 1, 2, 3 away from my center, and that's where another point goes. And then the other one was what, 5.2? 5.2 what? 30? Okay. So now for this one, I would count it out 5.2. So that would be right here. And then once again, I would count. That's 1.5 from my center. So now I'd go 1.5 and I would plot that same 5.2. Okay, so now I'm going to go to every petal. And I'm going to go 1.5 away and I'm going to plot 5.2. Like so. 1.5 away and I'm going to plot 5.2. Then I'm going to go 3 away and I'm going to plot 3. So I'm going to go out to my 3 marker and count 1, 2, 3 away. Whoops, not there, right there. 1, 2, 3 away. Wrong one. It's pretty tedious. And then I'm going to draw to the pole. We okay with that? So no matter what type of rows you have, you're going to have to do the 30-60 to get the width of your petal. It's always 30-60. If it's even, you have to do a min and a max. If it's odd, that's where it'll be a little different. Are we ready to do the next one? So if it is odd, this one, if it says it's got 3, then it actually is 3. We don't have to double it or anything like that. In this case, our petal length is 5. Cosine. Cosine equals 1 at 0 degrees, correct? That's its maximum point. So here we're going to do 5 cosine 3 times 0 degrees. And that's going to give me what? 5, correct? Because that's what I expect to get, the maximum length. So at this one, I'm going to count out 1, 2, 3, 4, 5. There's the length of my first petal. Now, if you have an odd number of petals, you do not have to do the minimum. It won't do you any good. If you have an odd number of petals, you need to equally space them from the first petal. This is the really important part. If it's cosine, it's always going to be 0, so it's not an issue. But if it is sine, it'll be plotted somewhere between 0 and 90. If it's plotted between 0 and 90, that means whatever number we're getting ready to get, you'd have to add to that one to equally space it. So you're always adding to that previous one. However, in cosine, it doesn't matter because it's 0. So to get this, we're going to take our 360 and divide it by, in this case, we have 3 petals to evenly space. So that means they will all be 120 degrees apart. Once again, in this case, it's not that complicated because we start at 0. Sine will make it to where you have to go from whatever point that is. So at 120, I'm just going to count out 1, 2, 3, 4, 5. And then where would my next one be? So 1, 2, 3, 4, 5. There's the end of all 3 of my petals. And you can see how it is symmetrical across theta equals 0, which matches up for cosine. Now we have to go find the width. So we're going to do the same thing, 30 and 60. So to do that, I have 5 cosine, and this is going to be 3 times what? 10 degrees. That means when I go to write my answer, it's going to be something 10 degrees. The other one's going to be 5 cosine 3 times what? And that means when I go to write my answer, it's going to be something 20 degrees. So I end up with 5 cosine 30 degrees, 5 cosine 60 degrees. What do we get for those? What is it?
4.3.
For 10? And then what do we get for 20? 2.5. Everybody okay with that? We got a second on this? Yes, no, maybe. Okay. So here we go. We got 4.3 at 10 degrees. So let's see. 4.3 at 10 degrees. I go 1, 2, 3, 4.3 is about right there. And then I'm going to go right over and plot the other. I'm going to go to my other 2 petals, and I know that they're 1 away. So I'm just going to go 1 away on each one and approximately at 4.3. That's totally not 4.3. That's more like 4.7. Let's put it on the other end of that. Then our other one was 2.5 at 20. So I'm going to go 2.5 at 20. And it's 2 away, so I'm going to just slide over and do 2.5. So then it's 2 away, 1, 2.5, 2 away, 2 away, and then 2.5, 2 away, and 2 away. These are always, it's worthwhile to look at them. I've had some of the craziest looking graphs before. Keep in mind, they're not going to be able to make you graph them. You got to be able to tell me characteristics about them. What's the characteristics of this rose? It has 3 petals, length of 5, symmetry with regard to theta equals 0. They're all 120 degrees apart from the longest point, correct? Okay. Question about any of that?